Okay guys, so this problem from the quiz, this was definitely the one that we struggled the most with, so I just wanted to try out this little video making thing to explain what's going on in this problem and sort of maybe rephrase it in a different way. So here's the problem essentially. I've got a syringe and it's got a plunger, and then I've sealed the end, and let's say that it's got 50 milliliters as a volume. And then we've got the syringe over here as well, but then in this room there's half as much air. So I've drawn in 10 air particles on this picture and only 5 air particles over here. So the volume that we start with, I'm really just making up a volume here, 50 milliliters. Sometimes that helps me visualize the problem or get it, understand it in my mind. And then for the pressure, we're going to say that the pressure is 1 atmosphere. So a normal room, the pressure outside will be 1 atmosphere, and this is a flexible container, right? So keep in mind that's a flexible container, so the pressure inside will be equal to the pressure outside. And we'll talk a little bit more about that in a second, but here's the question. So now the question is V equals question mark, pressure equals question mark. What's going to happen to the volume and pressure inside of that syringe when I sort of suck out the air from the room? So I've gone from 10 air particles to 5 air particles, and the question is what's going to happen to the volume and pressure inside of the syringe? Well, as soon as you do this instantaneously, right, the pressure now on the inside is going to be actually higher than the pressure on the outside. I've removed all of these air particles, so that will lower the pressure on the outside of the room. So we might say that the new pressure outside is equal to, say, 0.5 atmospheres, right? We've essentially cut the number of particles in half, so the pressure should sort of decrease as well. When the pressure decreases, the volume inside of the syringe, that's going to expand. So volume will increase. Another way to think about it is instantaneously, right? The pressure inside is higher than the pressure outside, so those will be bashing into the walls more, opening up that syringe. Now the pressure after it equilibrates, right, after that sort of instantaneous moment when we suck the air out, what's going to happen next? Well, the pressure will also decrease from the original 1 atmosphere, right, to over here, where now this volume will increase. The pressure inside of the syringe will also decrease. If this is a little confusing, another way to think about it is with balloons. I think balloons may be a better way for us to talk about flexible containers. For whatever reason, the balloons and syringes should really have the same type of properties. Both flexible containers. So here's my normal room, and I think in this picture, understanding why the pressure inside will equal the pressure outside, right, for a flexible container, might make a little bit more sense, might be a little bit more clear. So here's our flexible container. It's a balloon, and that balloon's going to stay the same size, right? If you are carrying around a balloon, the size of the balloon stays the same, and when we think about, okay, what's the pressures involved there? Well, these particles inside the balloon, they're going to be moving around, right? And they're going to be colliding with the inside of the balloon. They're going to be holding that balloon shape. These particles out here, they're also going to be moving around and colliding with the outside of the balloon. So the pressure on the inside will equal the pressure on the outside for any flexible container. So here we've taken that balloon and we sucked out half of the air particles from the room. So I think from this picture, if we're looking at this one, I think intuitively we all sort of say, oh, well, the balloon will get bigger, right? The balloon will get bigger, but then I want you to think about why the balloon's getting bigger, right? That's the real key. So yes, the balloon's going to get bigger again. And again, the pressure, because this pressure inside will have to equal the pressure outside, if we start with a higher pressure on the outside, then we go to less particles, the balloon will equilibrate to give us a lower pressure after that sort of process has occurred. Yep, I guess that's all I'm going to say for this. If you have any questions, obviously let me know, and hopefully we'll do this some more.